Now, Amendment 1 amends Section 722, which covers electric vehicle charging installations. It was issued on the 1st of February 2020 and may be implemented immediately. Any electric vehicle charging installations erected after 31st of July 2020 are required to comply with BS 7671/2018, incorporating Amendment 1 2020. The IET is the joint publisher of BS 7671 with BSI. BSI is the national standards body for the UK and is the copyright holder of standards emanating from IEC and Senelec, which is the European Committee for Electrotechnical Standardization. Amendment 1 to BS 7671/2018 is a standalone, free-to-view online document, or can be ordered via the IET website for a hard copy. Amendment 1 provides a list of definitions relating to charging modes. Charging modes categorise the type of electricity supply available at the socket outlets and are defined in most regards by international standards, i.e. IEC 62196. So let's look at Mode 1 in more detail. Mode 1 facilities are often described as slow chargers, as the current is limited to 16 amps maximum, which relates to an EU standard, and 13 amps maximum in the UK. Typical power ratings are 3 kilowatts for a single phase supply and 10 kilowatts for a three-phase supply. Now, Mode 2 is similar to Mode 1, but the cable between the socket outlet and the vehicle connector incorporates an in-cable control box. The charging cable has a pilot function to ensure the circuit protective conductor is securely connected before charging is allowed, and the RCD is for additional protection, which is part of the cable control and protective device. This device may also include a facility to allow adjustment of the charging level. Mode 3 facilities can be described as slow or fast chargers depending on the power available. With a maximum permitted current of 32 amps, typical power ratings are 7.4 kilowatts for a single phase supply and 24 kilowatts for a three-phase supply. It should be noted that although EVs may be able to connect to a 32 amp Mode 3 supply, some will continue to draw only 13 amps and as a result only charge at the slow 3 kilowatt rate. The main difference between Modes 3 and 1 and 2 is the use of control data pins, which provides a handshake between the vehicle and the supply. Mode 3 therefore provides a higher level of safety than Modes 1 and 2. Mode 3 also provides the capabilities offered by Smart Grid as the technology develops in the future. In summary, Modes 1, 2 and 3 provide methods of charging EVs using an AC supply, as we've seen in the previous slides. Mode 4 provides charging using a DC supply to the electric vehicle battery without using the car's onboard charging unit, which generally results in a faster charging time compared with Modes 1 to 3. The type of connector varies by vehicle manufacturer and power rating. The connectors shown here are the most common types currently available. Type 1 is the standard Japanese connector for electric vehicle charging in AC supplies, which has also been adopted by the North American countries and accepted by the EU. A Type 2 connector was appointed by the Commission of the European Union as the standard for regular charging of electric vehicles. A Combo 2 connector is the enhanced version of Type 2 with additional power contacts for faster charging. The CCS connector has been the standard for fast charging in Europe since 2017. The Type 4, sometimes called the CHAdeMO connector, which basically means charge on the move connector, operates exclusively with DC. It can be used for fast charging. It can be used to charge electric vehicle models such as the Nissan Leaf, Nissan e-NV200 and the Mitsubishi Outlander and many others. Now this table summarises the most common types of vehicle connectors, charging plug types and the different modes which we discussed earlier. Section 722 does not standardise on any one particular type of socket outlet or vehicle connector at charging points. but it requires these to be chosen from a list in section 722.55.101. The vehicle manufacturer instructions should be followed when determining the type of socket outlet or connector to be installed, as pointed out in a note in this section. You'll see in the table that Mode 1 is not generally recommended due to the lack of communication between the car and the charging point, and it needs to be assumed that appropriate RCD protection is part of the existing electrical installation, which might not be the case in some older electrical installations. Now, the scope of section 722 applies to electric vehicle charging installations. The requirements of this section do not apply to wireless charging, such as inductive charging and mobility scooters and similar vehicles of 10 amps and less. This Amendment 1 modifies the general requirements for protection against electric shock and includes specific requirements with regards to PME systems. Regulation 722.411.4.1 now provides 5 possible options. This will be discussed in the following slides. Most charge points currently installed simply supply power at a rate determined by the vehicle until fully charged. Several charging point systems now on the market feature smart charging, able to manage charging systems and control demand in real time, potentially decreasing or removing the need for expensive upgrades by the distribution network operator, or DNO for short. This diagram illustrates how load curtailment could be implemented. Smart charging adjusts the charging profile of the electric vehicles without overloading the system. You must always refer to the manufacturer's instructions for load curtailment requirements. If you have a number of electric vehicles at one location being charged at the same time in an uncontrolled way, they could increase the peak on the system, since charging trends could match existing load peaks and thus contribute to overloading the system. A PME earthing facility shall not be used as the means of earthing for the protective conductor contact of a charging point located outdoors, or that might be expected to be used to charge a vehicle located outdoors, unless one of the methods referred to in Regulation 722.411.4.1 1-5 is used. Amendment 1 2020 provides new and amended requirements around PME intended to keep pace with technology, whilst increasing the possibility for the installer or designer to use a PME earthing facility. We should also remember that there are several other installations and locations where precautions need to be taken when using a PME earthing facility. You'll see from the table locations such as agricultural and horticultural premises, caravan, camping parks, and similar locations, mobile or transportable units. Just so as you know, using a PME earthing facility will be discussed in more detail during this presentation for electric vehicle charging installations. Now, the publications, Electricity Safety, Quality and Continuity Regulations, and the Design, Construction, Modification, Maintenance and Decommissioning of Filling Stations, both publications provide precautions to be taken for PME earthing facilities. The latter is published by the APEA. So what is a PME earthing facility? Well, in a PME arrangement, the supply neutral conductor provides the functions of both protective and neutral conductors, often referred to as PEN conductor, and is connected to multiple earthing points on the supply network. The use of a combined conductor applies only to the supply and not to the consumer's installation. A PME has been almost universally adopted by DNOs in the UK as an effective and reliable method of providing their customers with an earth connection. However, in the event of an open circuit fault on the PEN conductor of a TNCS system, a potential can develop between the conductive parts connected to the PME earth terminal and the general mass of earth, creating a risk of electric shock to any person in simultaneous contact with conductive parts and the general mass of earth. Load currents may return to the origin of the supply via the protective conductors of the installation. This is shown by the red arrows in the diagram. This is the first option that we could use if we have a PME earthing facility. Regulation 722.411.4.1 indent 1 refers to a situation where a charging point is supplied from a three-phase installation used to supply loads other than charging points and where the load is sufficiently well balanced. The maximum voltage between the main earthing terminal of the installation and the earth in the event of an open circuit fault in the PEN conductor should not exceed 70 volts. You will see in the diagram, if you have a balanced three-phase system, you should have no current flowing in the neutral conductor. Annex A722 includes guidance on how to calculate the neutral current of a three-phase installation, and a formula to determine if the voltage between the main earthing terminal and the earth is below 70 volts in the event of an open circuit fault in the PEN conductor. More details can be found on page 13 of Amendment 1 2020 if the charging point forms part of a three-phase installation. The second option requires a very low resistance earth electrode connected to the main earthing terminal of the installation to mitigate the effects of an open circuit PEN conductor fault on the supply. In Annex A722, item A722.3 gives guidance on determining the maximum resistance required for this earth electrode. As you can see, the values of the earth electrode is exceptionally low and would be extremely hard to achieve in most locations. For indent 3, protection against electric shock is provided by a device which electrically disconnects the vehicle from the live conductors of the supply and from protective earth within 5 seconds when the voltage between the circuit protective conductor and earth exceeds 70 volts due to an open circuit fault in the PEN conductor. The device does not need to operate if the voltage exceeds 70 volts for less than 5 seconds. Closing of the device is by manual means only. A device that meets the requirement would have to measure between the CPC and a measurement earth electrode, or the CPC and a reference point in a three-phase system. A product standard for a protective device described in the previous slide for the purposes of Regulation 722.411.4.1 is being developed by the BSI Committee, PEL 23.1. Where indent 3 applies, the measurement earth electrode shall be placed outside the resistance area of any parallel earth that may exist. For example, where a buried metallic pipe is bonded to the main earthing terminal and outside the resistance area of any other earth electrodes. Where buried in the ground, a protective conductor connecting to an earth electrode for the purposes of 2 or 3 shall have a cross-sectional area not less than stated in Table 54.1 in BS 7671/2018. Regulation 722.411.4.1, indent 4, gives an option specifically for protection against electric shock in a single-phase installation by using a device which electrically disconnects the vehicle from the live conductors of the supply and from the protective earth within 5 seconds, depending on the voltage at the charging point. The type of devices described in indents 3 and 4 of Regulation 722.411.4.1 refer to monitoring the voltage between specific points. At the time of release of Amendment 1 2020, there is no specific product standards relating to these devices. Therefore, it is the responsibility of the electrical installation designer or other person responsible specifying the installation to establish that the manufacturer of the equipment has ensured that the equipment satisfies the safety objectives of the relevant directives. The final indent, 5, allows protection against electric shock to be provided by use of an alternative device to those in indent 3 or 4, providing that it does not result in a lesser degree of safety than using 3 or 4. The device could be located within the charging equipment or within the installation. Creating a TT earthing system for charging equipment or to the whole installation as an alternative to using a PME earthing facility with one of the methods 1 to 5, as just discussed, may not be an appropriate solution due to the inability to provide sufficient separation from buried metalwork connected to the supply pen conductor. Other possible problems with delivering a TT earthing system from a PME earthing facility in an installation may include ensuring sufficient separation below and above ground, and the possibility of striking existing buried services. In the event of an open circuit on the pen conductor, all the conductive parts connected to the PME earthing system can rise to a dangerous voltage above earth potential, which could be transferred to a nearby earth electrode. For determining the separation distances between different earthing systems, you should refer to the current version of BS 7430, and you should also carry out the appropriate risk assessments for any hazards that may exist. For example, is it possible to simultaneously touch any conductive parts that might be connected to the PME earthing terminal and the vehicle during charging? Some DNOs may have their own requirements for separation distances between different earthing systems, which may be different between each region within the UK. Electrical separation could be used to supply one electric vehicle. This protective measure would include an isolating transformer. Isolating transformers for domestic installations are generally supplied in a suitable enclosure that can be fitted to an internal wall of a garage or externally to supply an EV charge point. One of the possible issues of using an isolating transformer is the high inrush currents, and the overcurrent protective device should be selected accordingly to prevent nuisance tripping. The diagram on the right shows a typical scenario where we have a charging point located within a garage. So the question is, what type of earthing facility would be permitted if the charging point is located within a garage and the vehicle is unlikely to be charged whilst outside? Well, you might think that we are limited on the possible options that we could adopt. Could we have a TNCS or a TNS or even a TT earthing facility? In fact, we could have option A or B or C in this situation. Any one of these three options could be used. You see, if we take another look at Regulation 722.411.4.1, which says, a PME earthing facility shall not be used as the means of earthing for the protective conductor contact of a charging point located outdoors or that might be expected to be used to charge a vehicle located outdoors, unless one of the methods referred to in Regulation 722.411.4.1 to 5 is used. If the charging point is located at the front of the garage, then a PME earthing facility may not be suitable unless one of the methods referred to in Regulation 722.411.4.1, 1 to 5, is used. Nowadays, electric appliances, including single-phase inverters, are widely used in household and commercial, industrial applications to reach a higher level of efficiency, therefore reducing the energy consumption of the electric motors. The downside of using sophisticated electronics to control electrical equipment is the possibility of the increase in DC currents and frequencies above the normal 50 Hz. RCDs are sometimes selected to provide fault protection, additional protection, and in certain circumstances, protection against fire. RCDs are widely used, and therefore it's necessary for electrical skilled persons to have a sound understanding of this type of protective device. The requirements for RCD protection for Section 722 requires Type B, Type A or Type F RCDs to be used to take account of DC fault currents, except where it is provided by the EV charging equipment. If you're using a Type A or Type F RCD, You will also need a residual direct current detecting device, complying with BS IEC 62955, as appropriate to the nature of the residual and superimposed currents, and the recommendations of the manufacturer of the charging equipment also needs to be taken into account. An RDC-DD can be located inside the EV charging equipment, and the Type A or Type F RCD should be positioned upstream in either the charging equipment or the installation. Smooth DC residual currents greater than 6 milliamps could occur when electric vehicles are being charged. This goes beyond the design scope of conventional Type A or Type F RCDs. You will need to use a residual direct current detection device in conjunction with a Type A or Type F RCD to ensure correct operation. Let's consider this typical scenario. If you have an existing installation and your customer requires a charging point to be installed, you could possibly have two RCDs connected in series. What is the potential issue of having two RCDs connected in series and types shown in this diagram? The first thing we need to consider is how we achieve selectivity between two RCDs. The upstream RCD could be a Type S or time delayed, and the ratio between the upstream and downstream RCD should be at least 3:1. However, under some circumstances for existing installations, due to other requirements of BS 7671, selectivity may not be achievable. This will need to be discussed during the design stage. The other consideration is the type of RCD used upstream and downstream. The proper functioning of the RCD is ensured if the type of RCD is matched to the type of residual current expected. This might need consultation with the client, designer, or with the manufacturer of the equipment. Certain combinations of RCD types are not recommended because the operation of the downstream RCD has been selected for the load characteristics. A Type A RCD should not be fitted upstream of a Type F or B RCD, and a Type AC RCD should not be fitted upstream of a Type A, F or B RCD. Any wiring system or equipment installed should be suitable for its location and able to operate satisfactorily without deterioration during its working life. When you have charging equipment located outside, you require a minimum protection of IP44. Any charging equipment installed in public areas and car park sites shall be protected against mechanical damage by one or more of the following shown on the screen. Just take a second to read the options. Now the picture on the screen is of a charging point located at the car park at the select offices. And you'll see that it's fitted with a physical barrier to provide mechanical protection.